Right, fun stuff. Okay, now let's put this to a thing that we can actually use. There are two things that you have to keep in mind. First thing is, whenever you see a molecule, you have to first understand which is the central atom. Say I say methane, CH4. Which is the central atom? So you're trying to find out this thing. Which is the central atom? Why? Yeah, it's correct. But how did you just guess?
I imagine that because there's only one and there's 4 hydrogens,
Yes.
it has to be surrounded by
Yes,
an carbon.
correct. It's the one which is less in number.
It would make no sense if it was 4 hydrogens. Yeah, that's just, I
Yeah.
guess,
Yep.
mentally.
Yes. So the one that is less in number is just the central atom. It's like as simple as that. Now what if you have 2 atoms which are 1, like XeOF4, something like that. So if there is a molecule called like,
would it be the one that could take the most amount of bonds?
that is one thing, but that is very good. I have not thought about that, but that's true. That is actually very smart, yes. I think I don't need the other rule now, because that rule was made up by me. So
Xe is bonded to oxygen, and then you have your 4 atoms of fluorine.
yeah. So I was just thinking, like, out of Xe and Xe, you have 2 options now. There is one Xe and there is one O. Which is going to be the central atom? That was my question.
Both. Xe's
But Courtney says it's Xe, right? You guys fight now amongst yourselves. And Courtney will try to convince other people. Because you gave me a good answer.
Because I know that Xe, especially if there's like for that one especially, they can have extra bonds.
Don't talk to me.
Oh.
I know the answer.
I just know like in like regular chemistry when they talk about Xe, I know Xe can have, it's like a special one.
What is Xe anyway? I don't.
Noble gas.
Yeah, and like a really big one.
Yeah.
So it's helium, neon, argon, krypton, xenon. So it's like, so helium, neon, argon, krypton, xenon. Just like group 5, period 5. So like 5 shells. So it's a lot. So you can even have like an F, right?
Yeah.
So for 5. So 5F exists. Sorry. Yeah. 5F. So it has a lot of space to bring in. The other thing is, like, this is what I thought always, just if you keep the electronegativity, so one thing that is least electronegative will somehow be like the central atom. It's like another thing but I think Courtney's answer is much better, because it's like, if you have the space to accommodate, oxygen doesn't have the space. So it stops at 2p4. So it doesn't have the space to accommodate, and that's the reason the PCl5, it didn't. Clearly XeOF4 is an extended octet, because xenon has already a filled octet. So there's no reason for it to bond, but it does because it has the capabilities. It has a mansion, if you think about it. There's so much space. Okay? Yeah, so if we can understand that, then it really becomes easy now to predict. For example, for linear, if you give me an example, so now I think you would know how these things were getting translated. So for sp hybridization, where you have 2 hybrid orbitals, whenever you have an sp hybridization, you're getting a linear shape. So that was my idea. So 2 dogs, linear, 3 sp2, trigonal planar, 4 sp3, tetrahedral, 5 sp3d, this weird thing here, trigonal bipyramidal, 6 sp3d2, 7 sp3d3. And let's stop it there because I did not learn after that. And this will cover a lot of grounds anyway. But now, how do you find out which is sp? But now you know that anything that has an sp3 hybridization, if you can find out, you can say its shape will be tetrahedral. It's as simple as that. But how do you find out the hybridization? There is a formula, and let me see if I can come up with the formula correctly. This is what I do. I take in the central atom and I count the number of surrounding atoms. But I don't count oxygen. This will make sense, believe me, or maybe not. But this works. Plus the charge, if the charge is negative, so charge on an anion, just and subtract the charge on the cation. The number that you will get will, if this number turns out to be 2, the hybridization is sp, the shape is linear. If the number turns out to be 3, it is sp2 and it's trigonal planar. Let's try for methane. Let's start with methane. I think I'm missing something, but for methane it will work. Let me quickly check if I can. Okay, I missed something. Sorry. Outermost electrons. On central atom. Now it should work. So for methane, let's do methane. Okay. What's the central atom? Carbon. So what's the number of outermost electrons in central atom carbon? 4. So this is 4 plus number of surrounding atoms? 4. So the number becomes 4. 4 plus 4 divided by 2 gives you 4. What's the hybridization?
Tetrahedral.
Hybridization is sp3, shape is tetrahedral. Okay? Give me the shape of CO2 with this formula.
A bent.
Don't guess, just work it out. I will come to bent, but let's move from. So that cheat sheet is actually messing with your heads, right? Don't, that is for expert users, which you'll become in 10 minutes. CO2, come on, who got it? I'll give you many examples. CO2, so let's try for all these. CO2, I don't know, BeCl2, BH3, CH4, CH3 plus, CH3 minus, CH4 plus, CH3 minus. H2O, PCl5, PCl3, ClF3, I3 minus okay, let's keep at it. Let's do an easy one and then go for a more complicated one which have the ions. Which one you want to do?
Do CO2.
Do CO2. So what's the N for CO2? What's the number for CO2?
Of the outermost electrons?
Yes? No, I mean the final number.
Oh, 3 is what I got.
3? Who got 3? Who got 2? So carbon is 4 plus number of surrounding atoms. Don't count oxygen. So
So there's just 2?
it's 2. So what's the shape?
Triangle.
For 2?
Linear.
Oh yeah, I'm sorry, yeah. For 2.
Linear, right? So CO2 is linear. So it will be. So in this case, like the bonds will be double bond, but we'll see when one of them is a double bond and the other is a single. But in this case, this is linear and this is CO2. This is how it is. BeCl2 probably is also linear, right? Yeah. BH3. Yeah. So now.
You got to know your periodic table.
Plus.
Sorry.
I said you got to know your periodic table too. I don't know what boron is.
So
3 outermost electrons.
it's been period 13. 3 outermost.
Oh, okay.
Yeah. Once you get a hang of it, it will become really easy because clearly I made this thing up out of my head, but I read it somewhere and then it's the practice thing. So it's 3 plus 3, right? So you had 3 outermost electrons
So 6 divided by half.
plus 3 surrounding
So it's SP.
half. It's sp2 and it's trigonal planar. So let's do, we did methane, CH4. CH4 plus doesn't is not correct. CH3, I was right. So what about CH3 plus? What's the hybridization? Did anyone get a
4 plus 3 minus 1.
yes, 4 plus 3 minus 1 by 2.
Plus 7, 6, times 3.
3. So 4, because comes from the outermost electrons, surrounding atoms are 3, and you remove the charge on the cation. For CH3 minus, CH3 minus is 4, correct. So it's 4 plus 3 plus 1. Make sense? Because there is one negative charge, you just added that. Why did you add?
You're adding an electron.
You're adding the electron pair. It's whenever you have a negative, it's a pair. Yeah. And that this will come again into picture because this is not, I told this for a reason and we'll see in the case of H2O. So what's the shape of a CH3 minus now? So CH3 minus is sp3. Any problems with that? Is sp3, the predicted shape is tetrahedral, but the actual shape is not tetrahedral.
Is it a pyramid?
It is a pyramid. And why?
Because it's connected to 3 and then the top pair is.
Yes, correct. So this is the C, these are the H, and this is the electrons. You can't see the electrons. So what you see is this. Same for H2O. So in this, oxygen is the central atom. Okay? Because in this case, oxygen is the lesser number. So the number of outermost electrons in oxygen is 6 plus 2, 8. Divided by 2, it's 4. So it's The hybridization is sp3. The predicted shape is tetrahedral. But what's the actual shape? So there could be one here, 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 here. So you put 2 H's here, and that's it. So anywhere you put, the shape that you're going to actually see is a V shape. It's like a bent V shape. Bent because this is not 180, right? So the electron pairs of oxygen, which there is no negative, but there are like electrons, are sitting here. So the shape that you actually see is a bent. Okay, that's why water is bent shape, okay? Okay, let's do one more, which will give you, let's do I3 minus. One of them has to be a central. So the number of outermost electron on iodine is what? 7.
Sorry.
So it's in the halogen group, FClBrI. So for this it is 7 plus how many surrounding? 2. Because 1 it was itself, and there are 2 left. So 7 plus 2 plus 1. 5. So what's the predicted? This is the predicted, right? Now, so yes, sp3d, predicted is this, but what's the actual? I don't want to erase anything. So we know that this is going to be something like this. So I know that one I sits here. Which are the so now, the I3 minus has 1 negative. And there are also lone pair of electrons, and this is like a negative charge, right? So all these are like lone pairs of electrons. And how many bond pairs of electrons are there in this I? Let's think about that. There are 2 bond pairs. So the bond pairs can sit on the unstable positions. The lone pairs will go into the stable positions. Why? Because bond pairs are less energetic. They're generally stable. So if you put them in the unstable, it's fine. But with lone pairs, which are already unstable, if you put them in an unstable position, that will be not good. So you put the bond pairs of I3 minus in the unstable positions, which are these, and put the lone pairs in these. So what's the shape of I3 minus? And there is a negative charge amongst that. What's the shape that you see?
Linear.
It's a linear shape. So the predicted was trigonal bipyramidal. The bond pairs went into the longer, more unstable positions, and the lone pairs went to the stable positions because of this. And therefore, what you see, you don't see the electrons. What you see are the bonds, and this becomes a linear. Okay, cool. Please practice. There are so many examples that you can find probably. Yes?
I had a question about H2O.
Yeah.
Because I feel like you could kind of intuit that maybe the hydrogens would be like linear with respect to oxygen, because then they'd be equally distant from the lone pairs. But I mean, it seems like the hydrogens are closer to one lone pair than the other. Is there a reason for that?
I think it's the way we are seeing. We are trying to replicate like a 3D figure in here on a 2D plane. Okay. And that is why we are not able to actually visualize the...
So factually, the hydrogens are not more or less distant?
No, yeah, so they are like equally distant from both of them. It's right, yeah. It's not just like this lone pair is better, so let me get closer to that. It's not that. No.
Okay.
Yeah.
What is that formula called?
I don't know.
Term?
I don't think so. It's just a trick.
That may work.
Yeah. And that's why, like, I'm not trying. Okay, let me just. Yeah, I mean, we were taught this formula, and I think the formula will be there in that sheet.